Hello CAE users, welcome to Passion to Flirt with CAE for CAE engineers and freshers. Today in this session we are going to discuss about FE modeling of powertrain components using Tetra mesh. See, most of the powertrain components are casting components, they are too complex components. We are going to do most of the components we are carrying out with a Tetra mesh and hexa mesh. So today in this session we are going to discuss about a Tetra mesh. What are the rules and regulations we need to follow to carry out Tetra mesh? So as Tetra mesh is having 4 nodes and each nodes are having 3 degrees of freedom, because solid elements are having 3 degrees of freedom, that is, it is having only translation degrees of freedom, there is no rotation degrees of freedom. So Tetra is having 4 nodes, because of that we are having total 12 degrees of freedoms. Okay, fine. So next, see, majorly this tetra element which is having a major quality parameter as tet collapse. Apart from that, there are some other parameters are there, such as distortion, stretch. So those things we are not going to discuss in this session. We will discuss majorly with tet collapse. So we need to maintain 0.1 to 0.2. We need to maintain this. This is the quality parameter what we need to maintain. Before going to start with Tetra mesh, what we need to do is certain parameters we need to fix up. If we fixed up, so we won't be able to get any tet collapse problem after generating a Tetra mesh. So what we need to do is, we are creating a, before going to carry out a Tetra mesh, what we need to do, we need to carry out a shell mesh, right? So these shell mesh, they are of tri-elements we need to generate. So for those things we need to maintain quality parameters such as skew, aspect ratio and minimum angle of tria we need to maintain. So for skew, what we need to do, we need to maintain 55, maximum minimum angle of tria 20, 120 we need to maintain, and aspect ratio as 5. So what are the things we need to consider while doing Tetra mesh? First and foremost thing what we need to do is, we need to check the geometry, what is the geometry we are getting. So we need to check the geometry, right? We need to check the free edges are there or what, or duplicate surfaces are there, and sharing surfaces are there. So ultimately what we need to have, we need to have a volume of a geometry that should be closed one, right? So next, third point is very important parameter you need to remember. We need to find the critical region in our geometry or assembly. So what are the critical regions, such as cylinder like features, bolt holes and ribs, fillets, and assembly regions, means wherever one part is meeting with other part, those kind of things what we going to call it as assembly regions. And next point what we need to remember is, we need to check with the global element size and minimum element size, right? So fifth point is, depends upon the analysis how many rows of elements we need to maintain in critical region. Means critical regions are ribs, how many elements, so 2 rows, 3 rows, on fillet 2 rows or 3 rows, around the bolt holes how many rows of element you need to maintain. So these things plays very important role. So wherever these critical regions are there, no, so we need to use R trias, means right angle trias. Why means, so we need to get a proper flow of mesh to be maintained wherever critical region is there. So if the part is, one part is assembled with another part, wherever that interface area is there, no, we need to maintain proper flow. So by using R trias we can get that. So because of that we are using R trias. In planar areas we can use equilateral trias, so which will capture geometry very well, right? So in below slide you can see some powertrain components. So engine is there, transmission is there. So using this transmission, what we need to do, we need to adjust the transmitting power, we need to adjust, and differential is there, axle is there, exhaust system, mirroring system, that is steering systems are there, suspension system, braking system, electrical and electronic system, and cooling system. Apart from that, there are so many other components are there. For this is a simple presentation what I am going to give. These are the some few components what I mentioned over here, right? So you can see in below slide, this is the powertrain component, that is the transfer casing. So quickly I'll show you how to do Tetra mesh. For this component, we'll go to Hypermesh. So now you can see this is the transfer casing. This is the upper and lower parts are there, two parts are there, right? You can see, right? So these are the cylindrical features, right? See, this is the rib and these are the fillets. So these are the critical regions, and wherever the part which is assembling mating surface, this is the mating surface, these are the cylinders. So here what we need to do is we need to maintain R trias with specified number of elements we need to maintain in this region, right? So I'll take this part because more features are there. So you can do this also. So in this session I'll go with this, right? So what we need to do next step, what we need to do, so we need to create a critical region component. First we need to create a component, create it, generate it, right? Go to geometry page, defeature. So I need to organize these surface fillets and all. So I'll take 1.5 minimum fillet 1.5 to 40 radius, right? So displayed, find it. So you got these are the critical areas, right? So you can include these things also. These are the assembly regions. So you can include because they are like a cylinders, right? Then save these and go to shift F11, that is organize. So whatever the saved fillets are there, means saved feature, critical features are there, you can retrieve it and you need to organize with critical regions, right? So now you can see easily, right? So next we can visualize this component. If any free edges or any cracks are there in the geometry, whether it is closed or not, you need to check. Okay, so no free edges are there over here, so you need to confirm this, and after that you need to go to option, you need to set global element size as 5 and come back, go to F12. In this what I need to do, so you can switch off this, planar area, right? You can switch off with this planar area and you can work with this critical area. As I said, this critical area, these are the critical regions are there. So I'll take to minimum element, so I'll select those things and I'll mesh. So here majorly what you need to think is, this is the mesh what I'm getting, right? So in this region what I need to put, I need to put R trias, right? So you can split these things using shift F6 also, or you can select equilateral trias. You can do like this also. These are the two approaches, right? So then you got mesh. Now you can check. So got R trias on critical regions. Need to check like this, right? So then you can switch with planar areas. You can switch with this 5. You can go with equilateral trias. So here you need to use surface deviation. So element size. So what is your element size? That is 5. So growth rate I can take 1.2. Elements are growing, right? So minimum element size I'll take 2 over here, right? So I'll use equilateral trace and I'll select with unmeshed. Okay, unmeshed surfaces. So then you can mesh. So it is not showing minimum element size. I'll select. There are no unmeshed surfaces. So go with size and bias itself. Can select unmeshed. So okay, it is already meshed here. So no. Fine. Switch off this. You can. It is already meshed, right? So can go with surface deviation. You can select with this. It is selected, right? So you can set with closed volume proximity, free edge deviation, and then you can mesh it. Okay, then you can see how is your mesh. So it is good enough, right? So once you fixed up these things, what I need to do, you need to check with edges, find edges. I am having 3 edges, right? So hide this and switch with this free edges element. So you can see over here, right? So shift F5, you need to find attached. So we are getting elements over here, right? So what you need to do, this element merged over here and delete this and delete this. So another element generated over here, delete this. Then shift F3, delete edges. Then what you need to do, you need to unhide, check once again, find edges. So no free edges is there. Then go to T connection, you need to check. These are the 2 parameters, important parameter. Before going to generate Tetra mesh, what you need to do, you need to check with free edges as well as T connection. Using shift F3 you can check free edges, need to check, and next T connection. You shouldn't get any T connection. Here you will get around 21 T connections are there. So display, you to switch off these elements and you can check with this free edges. Go to shift F5, right? These are the T connection elements. So what you need to do, you need to delete. Simply you can delete these things. You have to delete these things, right? So even though duplicate elements are there here, right? So shift F3, delete edges. Then unhide all elements, So once again you can check with displayed find edges, no T connection, but into once again check with free edges, whether free edges are there or not. You need to check. This is very important, guys. No free edges and no T connections. Then what you need to do is you need to check with these qualities. Aspect ratio. If aspect ratio, before you to check with aspect ratio, you can select with shortest edge, just setting into done, setting, and then you can check with aspect ratio and skew into maintain 55, what I said. So no skew failed but aspect failed, and minimum and maximum angle, this is the element failed. So these things you need to fix up. How exactly these things you are going to fix? So aspect, if aspect elements are failed, simply I'll show you one row of elements, F5. So already I saved those elements. You can retrieve, mask and reverse. So these are the element they failed, right? This is the so tiny kind of elements are there. If you want to fix up these things, I'll show you. See, this element is there, no? So go to Shift F5, find attached. So these elements will get it. So what you need to do is go to element size and bias and fix up, and you can. So I'll show you one thing. You can increase 2, right? And you can split this thing, Shift F6, right? Divide chords by shortest diagonal. So I split it, right? Now you can check aspect ratio. So it is clear. Like this, what you need to do, you need to fix up the aspect ratio specifically for while doing Tetra mesh, right? Then, so and maximum and minimum angle you can fix up with by remeshing the things, right? So now what I'll do, I'll create component as Tetra, right? So create, so Tetra component was generated. Then go to 3D Tetra mesh. So directly you can create Tetra mesh. So in this, go to Tetra mesh parameter. There are so many parameters are there. You can control maximum Tetra element size and minimum Tetra size, and these are CFD reasons. CFD things are there. So I'm not going to deal with these things at this instant. And there are so many other parameters are there over here. So in next session or some other section, we are going to discuss about these things, right? So in this session, optimize mesh quality and stand, this is sufficient. So go to Tetra mesh, select this component and mesh it. So before going to that, mesh to current component. Tetra is the current component, right? What you can see. Then mesh it. It takes some time to create. The meantime, so most of the powertrain component we are doing Tetra mesh. So we are using first order as well as second order. So I'll show you how to convert. This is the first order element, right? So how we need to convert to second order, right? So in the meantime, we'll discuss about this Tetra. So Tetra element is like see, it's like a honeycomb. So this is tria, like and after that you can join these things like this, right? And this is joined like this. So from this is a flat region. From this base to this is the height, right? This is the height, and this is the area. This is the base area. So TET collapse. So I told that you need to maintain in this range 0.1 to 0.2. Okay. So how exactly we need to calculate this? TET collapse means height. This is the height you need to consider, and this is the numerical value. This is a numerical value 1.24 into this area. You will get TET collapse, right? So this is how TET collapse in software will check, right? So it is generating. So these quality if you must maintain to avoid this TET collapse, right? It's a very important parameter what you need to consider while doing Tetra mesh. And other thing, so simply I'll explain summary about these elements Tetra mesh. So what we need to do is, so insert slide over here and so first and foremost thing what I need to do, critical reasons you need to maintain using our trias. Planar area you can maintain with equilateral trias, and check with free edges and T connection, right? So you can check these things using Shift F3. Shift F3 is the shortcut what we are using in Hypermesh, right? Using this you can check, and check with shell quality parameter, that is aspect ratio to check, and next thing what you need to check with skew and maximum and minimum angle of try you need to maintain. If you maintain, you won't get 99%, you won't get TET collapse, right? So these things you need to keep in your mind. Which are the critical reason, what are the bigger component maybe, what are the complex component maybe. So you can use the trick. So what are all the critical reasons are there, you need to organize properly, and of that first you need to mesh properly those things, and remaining planar area you can mesh it easily, right? So quickly we can check whether it is generated Tetra mesh or what. So these many elements it is generated, right? So quickly we can check with, we can hide shell elements and we can check, see how the Tetra mesh is, right? So see, you need to mesh like this. So I'll show you. Go to F5, you can mask this, right? So this is your mesh, right? This is a Tetra mesh, right? So unmask all, mask and reverse. So I told that Tetra mesh having 4 nodes. Go to Shift F2 again. So each 4 nodes are having 3 degrees of freedom, total 12 degrees of freedom, right? So next what we're going to do is we need to go to F10, we need to go switch with 3D, we can check with TET collapse. I told 0.12, okay, check 0.12. So around 156 elements are failed because we didn't maintain certain qualities, right? So I'll show you how to fix up this. F5, retrieve, mask, reverse, right? So these things are like a plate element. So by seeing these things, they are looking like a plate elements. Go to Shift F4, select these two nodes, and you can translate. No, in that direction you can translate. Now you can check with TET collapse. So they are cleared, right? So like this you need to remove the TET collapse. So if you maintain quality, so it is not necessary to worry about this TET collapse, right? So now I'll show you how to convert these things to second order. Go to 3D page or a 2D page, you can see this order change. See guys, this is very important setting what I need to do. So these are the first order element, right? So I'll show you. See, now you can see this is the first order element, right? So now I'll show you how to convert to second order, right? So select these elements, go to order change to second order. So keep in your mind this setting, you must do it. Mid-side node must be projected to surface. So on geometry, after converting these things, these mid-side, whatever the mid-side nodes are there, no, they must project to the surface. So this setting if you are doing, so generally these mid-side nodes of second order element will project, and it will capture more geometry properly. So that's why you need to do it. So you can convert, change order. So it will take a little bit more time because last together elements are there. So second order changed, right? So it is not, now it convert to second order. We need to check whether it is converted to second order or not, right? Continue. Still it is converting. You can see what are the things are going to happen at the status bar, you can see, right? Scanning bad elements and all, right? Now second order element generated. Now what you need to do is you can mask one element, I'll show you, right? Reverse. You can put nodes, see? Now you can see this is second order element, right? So well guys, these are the parameters. What are the parameters I explained? You need to consider those things while doing tetra mesh. Okay, and if you followed those tips and tricks, you will get a you can create tetra mesh very smoothly and easily without any problems. Okay, well guys, thanks for watching this video. If you like this video, you can like us and subscribe us, and you can share with your friends. Thank you.